Welcome to this explainer. Okay, so for thousands of years, the lost city of Atlantis has literally been the ultimate unsolved mystery. It's inspired countless movies, books, and, some pretty wild internet theories. But what if we stopped looking at it as a myth or a magical fairy tale and instead treated it as a strict, measurable scientific problem? Today, we're taking a completely data-driven approach to the hypothetical location of the Atlantis civilization. We're putting aside the crystal energy and the fantasy, and we're going to look at actual science, geography, and geology to see how modern researchers are trying to solve the world's oldest cold case.
Okay, let's dive right into this. The core mystery we're facing today is a big one. How do you find a city that might not even exist? I mean, it's a massive challenge, right? If you just guess and start digging, you're going to waste millions of dollars. To solve this, we really need a reliable framework. We need basic, logical rules. So we're going to apply a strict scientific method to see if there are actual physical leftovers of a lost civilization.
So here's our roadmap for this explainer. 1. The search problem. 2. The THD hypothesis. 3. The Gulf of Cádiz. 4. Validation tests. And 5. Real-world impact.
All right, Section 1, the search problem. Let's look at why past searches have completely failed.
Before we actually find anything, we got to understand why past explorers came up entirely empty-handed. For centuries, people just kind of picked a spot they liked and forced the evidence to fit. Historically, people fall into 3 camps. First, there's a literal Atlantis, which would be a real, testable city. Then, a composite Atlantis, which is basically just mixed up memories of various coastal disasters. Or an allegorical Atlantis, which is a pure, untestable metaphor. Because everyone constantly argues over these interpretations, the search has just become a confusing mess.
Moving on to Section 2, the THD hypothesis, which gives us a brand new framework.
To fix this massive problem of how we understand Atlantis, we really need a way to look at the data objectively. For this, we turn to the groundbreaking research of author, researcher, and inventor Kevin L. Brown. He created a new framework, and his core philosophy is captured perfectly right here. He says, "This paper does not assume Atlantis was real. It defines what must be true if Atlantis had a physical basis." This is a massive shift in thinking. Brown isn't saying he actually found Atlantis. He's saying, if it ever existed as a real physical place, well, here are the exact clues the Earth would have left behind.
This specific approach is called the Triune Harmonic Dynamics, or THD hypothesis. In simple terms, THD is a framework that searches for a degraded high-structure system. Now, what does that actually mean? It means we aren't out there looking for intact magical fantasy palaces with golden pillars. No way. We're looking for measurable leftovers. If a highly organized city was wiped out, it's going to leave behind a footprint. We're talking about unusual geometric shapes in the ground, deeply buried sediment layers from a massive flood, and measurable changes in the dirt that honestly only happen when humans live somewhere for a long time.
Section 3, the Gulf of Cádiz. This is the exact real-world location the data actually points to.
Now, what's really interesting about this is when researcher Kevin L. Brown ran the data through this strict THD framework, it pointed strongly to one specific region, the Gulf of Cádiz, right near Spain. And this isn't just a random guess. It has an Atlantic-facing geography that matches ancient descriptions, and it sits right near the Pillars of Hercules. Plus, the ancient terrain was absolutely perfect for a thriving coastal settlement. Crucially, it has huge catastrophe potential, with a known history of massive tsunamis and marine flooding. Finally, it sits right on ancient trade routes, meaning any survivors could have easily passed the story of their destroyed city on to others. It literally checks every single box.
You might be wondering about other famous internet theories, like the Rashad structure in Africa, which is often called the Eye of the Sahara. The Rashad structure is super popular online right now because it looks exactly like a giant bullseye from space. It definitely has a strong visual resemblance to the Atlantis myth. But here's the thing. Visual resemblance just is not enough. Geologists have proven the Rashad structure is a completely natural rock formation. The Gulf of Cádiz, on the other hand, gives us high structural convergence. That means multiple layers of independent data, like geography, geology, and archaeology, all stack up in this one single spot. And that is exactly what makes it testable.
Okay, Section 4, validation and falsification. How we actually test the theory.
Just having a good idea isn't enough, right? We have to actually test it. Modern scientists don't just use shovels and treasure maps anymore. They use high-tech validation test mechanisms. First up, sediment cores. This means drilling deep tubes of dirt out of the ground to look for ancient tsunami layers. Second, marine magnetometry and sonar, where they drag sensors behind boats to map out unnatural geometric shapes buried deep under the ocean floor. Third is LiDAR, which is shooting lasers from airplanes to see right through modern vegetation and spot hidden ancient structures. And finally, controlled excavation, which is carefully digging up specific targets to find datable human artifacts.
So, the crucial point here is that for any scientific theory to be valid, it absolutely must have falsification parameters. These are conditions under which the theory can be proven entirely false. Kevin L. Brown's THD model embraces this completely. The hypothesis is dead in the water if scientists look at the Gulf of Cádiz and find that the strange shapes are just natural marsh and river processes. It's false if no datable human materials, like pottery or tools, are found. It's false if the deep dirt shows zero sign of a sudden catastrophic flood. If nature explains it all, the Atlantis hypothesis for this location is officially over. And honestly, that is just good, rigorous science.
Finally, Section 5, Real-World Implications. Let's talk about why this actually matters.
So, why does all of this actually matter to us today? Well, it builds a much better future for archaeology in two key ways. First, discovery. This framework completely shifts the whole Atlantis conversation from wild speculation and internet rumors into ranked scientific field tests. Second, policy impact. Look, archaeological expeditions are incredibly expensive. Millions of dollars are at stake here. By using the THD model and looking for measurable data convergence, scientific institutions can prioritize their funding. They can finally stop wasting money on wild goose chases and spend it wisely on the sites that are actually most likely to yield real historical breakthroughs.
Which leaves us with this final, thrilling question. Are we on the brink of turning the greatest myth into measurable history? By applying Kevin L. Brown's strict data-driven THD framework, we're no longer just dreaming about a lost city. We're actively scanning the coastlines, drilling into the earth, and letting the actual data speak for itself. Whether the Gulf of Cádiz holds the ruins of an ancient empire or just the natural remnants of a catastrophic flood that inspired a legend, we now have the exact tools to find out the truth. Thank you so much for joining me on this explainer, and stay curious.